Out there, beyond the farthest stars our ancestors could imagine, light has been traveling toward us for nearly the entire age of the universe. For billions of years, it crossed expanding space, slipping between forming galaxies, surviving cosmic chaos, only to arrive now on Earth. And when astronomers finally caught that ancient light, they realized something was wrong. The galaxy it came from shouldn't exist, at least not yet. This is the story of a galaxy so distant, so early, that it forces us to question how the universe grew up so fast. To understand why this discovery is unsettling, we need to begin with a simple truth about space. When we look far away, we are also looking back in time. Light has a speed limit. Even at nearly 300,000 kilometers per second, it takes time to cross the vastness of the cosmos. So the glow from distant galaxies is a kind of fossil record, showing us what the universe looked like long before Earth existed. Our own galaxy, the Milky Way, is about 100,000 light-years across. The light from its far edge began its journey toward us before modern humans walked the planet. But the galaxy astronomers recently observed lies not thousands, not millions, but over 13 billion light-years away. That means its light began traveling when the universe itself was barely a few 100 million years old, an infant cosmos, a time when the first stars were only just igniting. And yet, what scientists found there looks anything but infant. In the earliest chapters of cosmic history, the universe was a very different place. After the Big Bang, space was filled with hot, glowing plasma. No stars, no galaxies, no planets. As the universe expanded and cooled, tiny variations in density slowly grew under gravity's patient pull. Gas gathered, dark matter formed invisible scaffolds, and eventually the first stars flickered into existence. Astronomers believed this process was slow and gradual. Small clumps formed first, then merged over time, building larger and more complex galaxies across billions of years. According to this picture, massive, well-organized galaxies shouldn't appear until much later. They need time to grow, time to form stars, time to shape structure. But this newly observed galaxy appears far too mature, far too soon. It's not a faint smudge barely holding itself together. It shows signs of structure, of mass, of stars that have already lived and died. And that raises an uncomfortable question. How did it get there so quickly? The discovery was made possible by humanity's most powerful eye on the universe, a telescope designed not just to see far, but to see early. Unlike optical telescopes that capture visible light, this instrument observes infrared wavelengths, light that has been stretched, reddened, and softened by the expansion of space itself. As the universe expands, light traveling through it gets pulled apart, its wavelength grows longer. What began as bright ultraviolet radiation from young stars arrives at Earth as faint infrared whispers. By listening to those whispers, astronomers can detect galaxies at the very edge of time. And when they did, they expected to find chaos, small, messy, irregular shapes struggling to assemble. Instead, they found order. This galaxy appears to contain a surprisingly large number of stars, stars that must have formed rapidly in an environment that should have been hostile to such efficiency. Even more puzzling, some of those stars appear older than expected. Their light carries chemical fingerprints suggesting earlier generations already lived and died. In cosmic terms, that's like discovering a bustling city where there should only be scattered campsites. Something doesn't add up. Either stars formed much faster in the early universe than we thought, or our understanding of how galaxies assemble is missing something fundamental. Or perhaps the universe itself behaved differently in its youth. One possibility is that early galaxies were extraordinarily efficient at turning gas into stars. Gravity may have worked faster in denser conditions. Collisions between gas clouds may have been more frequent. Another possibility involves dark matter. This invisible substance makes up most of the universe's mass, yet barely interacts with light. If dark matter clumped more tightly in the early universe than expected, it could accelerate galaxy formation, providing deeper gravitational wells for gas to fall into. There's also the unsettling idea that some of our assumptions about cosmic timelines are incomplete, that the universe may have had periods of accelerated structure formation we haven't fully accounted for. Each explanation opens new questions, and none fully resolve the mystery. What makes this discovery particularly troubling is that it's not alone. Astronomers are finding multiple galaxies like this, each one appearing earlier than predicted, each one challenging the slow, orderly story we told ourselves about cosmic evolution. Individually, they are anomalies. Together, they suggest a pattern, a universe that learned to build faster than we expected. This doesn't mean our models are wrong in the way a broken clock is wrong. It means they may be incomplete, like trying to understand a forest by studying only one tree. The deeper scientists look, the more the early universe reveals itself as a place of extremes: extreme density, extreme energy, extreme speed. Stars were massive and short-lived. Galaxies collided and merged frequently. Radiation flooded space, reshaping matter itself. It was a universe in a hurry, and this galaxy may be a relic of that urgency, a survivor from an era when cosmic rules were still settling into place. Yet even with the best instruments ever built, there are limits to what we can know. At such immense distances, limits blur. Light is faint. Interpretations rely on models and probabilities. Astronomers are cautious. They debate. They reanalyze. Is the galaxy truly as massive as it appears? Could dust be misleading our measurements? Are we interpreting its light correctly? These questions are not signs of weakness in science. They are signs of honesty, because the universe does not owe us simple answers. What remains certain is this: we are witnessing the universe revealing its childhood, not as a quiet, orderly process, but as something wild, fast, and surprisingly capable, a cosmos that learned to shine long before we thought it could. And somewhere in that ancient light, carried across billions of years, is a message that no matter how much we think we understand the universe, it still holds the power to surprise us. And as you look up at the night sky, remember this: every point of light is a time traveler, every galaxy a chapter in a story still being written, and some chapters arrive earlier than expected. Perhaps the universe has always been more creative, more efficient, and more mysterious than we imagined. And perhaps this distant galaxy is not a problem to be solved, but an invitation to keep looking deeper, to keep listening to ancient light, and to accept that the universe, even after billions of years, is still capable of changing how we see everything.